Corrosion will never stop. Don't let it start. According to the National Association of Corrosion Engineers, NASA, the annual cost of corrosion to U.S. utilities is approximately $50 billion. Corrosion creates a dangerous and costly condition inside of a substation. Here we see a substation earth grid 36 inches below grade, designed as a Faraday cage to protect the workers and equipment inside from abnormal overvoltages caused by electrical faults. We now take a closer look at a cross-section of the copper weld ground wire used for an earth grid. We see the wire is actually a bimetal with a steel core and a thick copper shell metallurgically bonded together via the copper weld process, meeting ASTM B910. Let's take a closer look at the difference between copper weld ASTM B910 with a true metallurgical bond versus substandard wire not meeting ASTM B910, where the metallurgical bond only exists intermittently over the thousands of feet of wire required to build a typical earth grid. A metallurgical bond is characterized by a consistent alloy layer void of any space between the two bonded metals. The steel of the core and the copper of the shell intermix at a molecular level to prevent any chance of galvanic corrosion. A metallurgical bond is actually stronger than the two metals it unites. Galvanic corrosion is the single greatest root cause of earth grid failure in the industry. On the other hand, wire lacking a true metallurgical bond leaves microscopic seams, voids, and gaps between the two dissimilar metals, creating a difference in voltage potential ripe for galvanic corrosion. Unavoidably, as a result of substandard bonding processes, there already exists an electrical medium as molecules of H2O and oxygen are trapped within the microscopic seams and gaps between the two metals. When this wire is buried, external moisture, temperature, and soil acids collude to accelerate the corrosion process. Copper being more noble than steel, it robs the steel of its electrons, creating a voltage field that can even be measured. Conductive soils are notoriously corrosive, which doesn't help substandard ground wire to withstand the already harsh conditions. Soil friction and stray voltage make things worse. Once an iron molecule loses an electron, an oxide ion immediately forms with any oxygen, H2O, or acid ions present in the medium. Oxides are many times more massive than the iron molecule they replace, which build up and puts pressure on the copper shell. The mound of oxides continues to grow. This puts pressure on the protective copper shell above, leading to cracking, creating paths for the outside elements to enter. The floodgates are now open to accelerated atmospheric and galvanic corrosion. Intergranular and carbonic corrosion are precipitated by the steel's exposure to the atmosphere, accelerating the mounding of pressure-inducing oxides, sulfides, and carbonates. This serves to further crack and peel back the copper cladding. This process will continue until all of the iron molecules are oxidized and removed from the core, leaving a cracked copper tube in its place. At this point, the ground grid has been compromised and is no longer in full control of abnormal current. This leads to a hazardous and destructive condition for the substation. Corrosion breaks the links in our Faraday cage, exposing equipment and workers to transient and ground faults. Normally, when the earth grid is safely intact, surges caused by routine clearing, conductor clashing, tree contact, or by lightning strikes are safely directed to ground by the grid path. But when corrosion breaks a clear path to ground, essentially eliminating links in the grid, hazardous fault currents can seep from its cage searching for a new path. Once free, stray current is unpredictable. It can backtrack into the substation seeking a new path to its source. To avoid this condition, it is essential that the correct corrosion-resistant materials be utilized when building an earth grid. The standard ASTM B910 was created to let utility managers know that a metallurgical bond exists in the material and that the risk of galvanic corrosion is eliminated. Every inch of copper weld ground wire meets ASTM B910. With copper weld, the substation is safe. Do not be fooled by substandard or counterfeit materials claiming to meet the standard. Grounding materials should be tested by a metallurgical lab before application.